So by any chance, anybody watching recording? There was no audio before this, so I've cut off that much recording and we'll be starting from here. Okay. So again, I'm hoping that you'll be able to solve this. If you have again problem in this, you can ask me again later. Okay. So we'll go to chapter 14 assignment, question 4 and question 16. Question number 4. Explain what is meant by the expectation theory. Okay, of course, that is the theory question. Then second part, short term, 1 year annual effective interest rate are currently 8%. They are expected to be 7%. So see, short term 1 year annual effective rate of interest. Currently, that means from time 0. So they are saying forward rate from time 0 for 1 year, that is nothing but y1. Okay, y1 will be equal to 8%. They are expected to be 7% in 1 year's time. So f of 1 comma 1 is supposed to be 7%. Then 6% in 2 years time. 2 comma 1 is 6%. 3 comma 1 is 5%. Okay. Calculate the gross redemption yield from 1 year, 2 year, 3 year, 4 year, 0 coupon bonds. That means y1, y2, y3. Okay, so we'll say y1 is equal to f 0 comma 1, that would be equal to 8%. 1 plus y2 whole square will be 1 plus y1.
Excuse me, sir.
Yes.
The doubt is in the C part. You can fix this.
Yes, but I need to calculate these for our calculations. So we understand how to solve this. I will just see from the solution, hoping that they are correct. 7.4988%. Then similarly y3 would be 6.997%, and y4 6.494%, and y5 would be 6.562%. No, that is not y5. I think that is answer of B. So we will be going up till only y4. Okay. B part, the price of a coupon paying bond is calculated by discounting individual payments from the bond at the 0 coupon yield. In A, calculate the gross redemption yield of a bond that is redeemed at par in exactly 4 years and pays a coupon of 5 per annum annually in arrears. So first we'll find price. Price is going to be coupon, that is 5. Okay. And we'll have 1 by 1 plus y1 plus 1 by 1 plus y2 whole square plus 1 by 1 plus y3 whole cube plus 1 by 1 plus y4 whole raised to 4. And then plus redemption is 100 upon 1 plus y4 raised to 4. You can say 1.08 raised to minus 1 plus 1.074988 raised to minus 2 plus raised to minus 3. So we have price as 94.6755 per 100 nominal. Now we have to find gross redemption yield. So 94.6755 is giving us 5A4 plus 100 V raised to 4. Let's find I. So values between 6% and 7%. Six five six six. So the nearer value seems to be 656. So the gross redemption yield is 6.56%. C part, a 2-year forward contract has just been issued on a share price of 400. Okay, forward contract is not part of our course, so this C part is not actually part of our course. Okay, dividend of this is expected in exactly 1 year's time. Calculate forward price. Yeah, forward price is not part of our course anymore. It used to be, not now. Okay, so C part, leave it. Then 16B. An insurance company has a liability of 2 million per annum payable continuously for the next 10 years. The company values these payments using an effective interest rate of 7% per annum. This is also the interest rate at which the current price of all bonds are calculated. Okay. In order to meet its liability, the company invests an amount equal to the present value of these liabilities in the following two assets. We have zero coupon bond in 3 years time and a fixed interest bond redeemable at par in 7 years time, which pays a coupon of 8% per annum annually in arrears. Calculate the present value and the duration of the liabilities. So insurance company has a liability of 2 million per annum payable continuously for the next 10 years. So question 16, A part, present value and duration. Yep, I'll just make the equation. So present value will be 2 million and we'll A for 10 years, right? Payable continuously, A bar. And then for duration, we'll calculate summation T Ct V raised to T will just be IA the complete bar, 10. Okay, and then duration we know is going to be summation TCT V raised to T by present value. Calculate the amount of money that should be invested now in each assets if the duration of the asset is to be equal to that of the liability. Okay. So let's say I will be calculating everything per one nominal so that whatever variable I take, I will be getting the correct answer. So if I say A amount invested in zero coupon bond and B amount invested in the second bond, A amount and B amount. So for zero coupon bond that is redeemable in 3 years, the present value for that bond, present value of A is how much? It will just be 1 V raised to 3 because we are assuming for 1 rupee bond. This is the price that we are talking about. And present value of B, that is our second bond, we are talking about redeemable at 7 years, payable 8 per annum annually in arrears. So 8 is per 100. So I will write 0.08 A for 7 years and then plus 1 redeemable at times 7. Okay, so let's calculate this at 7% rate of interest. So the present value of our assets will just be A times present value of A plus B times present value of B. Okay, so that will just make it as 0.816297 A plus 1.05389 B, right? This is our present value. Then summation T Ct V raised to T for assets. So in that case, here I will be just multiplying with 3. Okay. So I will have A into 3 into 0.816297 plus here I will get 0.08 into IA. Okay, so 0.08 into 8 due minus 7 into 1.07 minus 7 on 7 plus 7 So we'll have 5.9675813B. Okay. Now we have two equations. Okay. Now I deliberately kept it like this because I would like to make a equation that is our present value of assets must be equal to present value of liability. That will be our equation 1, and DMT of asset will be equal to DMT of liability. Now instead of calculating the DMT, okay, do we have DMT here? Yeah, they have given DMT. I will be calculating the summation values. Okay, so our summation TCT V raised to T for liabilities will just be the DMT into the present value. Okay, so I will just get 4.4404 into okay, this is our summation TCT V raised to T of liabilities. This we were supposed to get from the first part. Okay, so because of Reddington's first two laws, we will say this must be equal to the present value, okay, and this must be equal to the liability. So what I'll do is I'll make the liability formula first. Is equals to 645332221.28 and and second one I will just, this will be equal to the present value. I'll multiply by 3 because I want to make it into this. I'll say A into 3 into 0.816297 plus this much into 3B. So I'll have 1.05389 into 3. That would be 3.16167B is equal to present value into 3, 145,33200 into 3. Subtract. We have 2.80591B equal to 2093361.28. So our B value I may have made small mistakes because you can see the B value here is slightly higher than this. Please check my calculations later. Okay, but I hope
Sir,
you
even
understand.
I got the value around this. I
So
got the value around this.
you're also getting value around this only, right?
Yes.
So maybe their calculation is not correct. Okay.
All right.
Sometimes that happens while calculating, they are not taking the correct values and final answer, especially these are not exactly examination questions. These are made by some other teachers. So what happens, sometimes calculation mistake occurs. So I guess you understand now how to make it. So let's go to our next We'll go to chapter 15, book questions. Okay. What was the page? Page 28. Page. Now, one of the doubt was about guaranteed annuity. Don't study guaranteed annuity how it is written in your book. I will be teaching you when it is relevant. Okay, right now guaranteed annuity is not relevant. We will be studying it later on. Okay, so don't worry. I'll be talking about guaranteed annuity with examples. Page number 28. Okay, page number 28. They are saying assuming that the force of mortality increases with both age and policy duration, comment on the expected relationship between the following pairs of the values. Now see, this is all about the understanding. What they are saying is the force of mortality increases with both age and policy duration. Okay. So policy duration after this will be how much? That is our select policy duration and stuff. Okay. Comment on the expected relationship between the following pairs. Okay. So we know that when more number of policy duration is left, then we will have more force of mortality. Okay. So here when we say selected at age x plus 1, that means let's assume if our policy duration or select period is supposedly, let's say 2 years. Okay, like we had in AM92. So here we had 2 years left for this policy duration or whatever select mortality that we are talking about. Okay, select period. Here we are left with only one because 1 year have already gone. It was selected 1 year ago. So clearly our mu select x plus 1 would be higher than, okay, no, mortality, force of mortality increases. Okay, sorry, we should see they are related to the same age. Okay, they are related to the same age. This is also x plus 1, this is also age x plus 1, so age factor does not matter here. Policy duration, so you might say that this person took the policy today, that is why the person was selected today, whereas this person has taken policy 1 year ago, right? There 1 year has already passed from which this person took the policy. So policy duration for this is higher, so therefore the force of mortality would be higher, because they have already said that our force of mortality, our mu, we'll say is proportional to x and also proportional to policy duration. So whichever has a higher policy duration will have higher mortality. So here policy duration is higher for this one, so it has a higher mortality, force of mortality. What about these two? These two again same age. This is x plus 4, this is x plus 4. But here you can see it is the person has been selected at age x plus 4, whereas here the person has been selected 2 years ago. So this will have the higher force of mortality because it has a higher policy duration. Now here we have x plus 4 selected today and x plus 3. First of all, age is higher here. Okay, the person has a higher age here versus here, but here policy duration is higher. So it will depend on how much effect does it make and which one will be higher. So we cannot say for certain which one is going to be higher just by looking at here, because here this one has a higher age whereas this one has a higher policy duration, right? I hope that is how they have explained this. Yeah, this seems correct. Here how this compares to this will depend on how duration and age affect the mortality, because the current age has decreased, reduced mortality rate, while the duration has increased. So that is what we just said, right? So this is about understanding. How do you understand the effect of age and policy duration? Then let's say 15.5 and 15.6. 15.5 M92 table is based on the mortality of assumed male life in the UK. Okay. Assured male life in the UK. As there is no corresponding mortality table for the female lives, in order to calculate the survival probability for female policyholders, an actuary decides to use the M92 table but with an age rating of 4 years applied. That is, female age X is considered to experience mortality equivalent to a male aged X minus 4. So female are experiencing less mortality. Okay, it is directly related here. Explain the rational underlying approach. Okay, so we have always observed that the mortality rate of female is less than the mortality of male in all other tables. So we are assuming that there is an age gap of 4 years. Okay, so then calculate the probability that a female policyholder age 62 survives for at least next 10 years. So you are talking about probability that female age 62 survives for next 10 years. Okay, but if we convert it into AM92, it is same as X minus 4. So it would be same as 10p58 from AM92. Okay. So you can find this. This will be our L68 from AM92 upon L58 from AM92. You can find these. Then the second part, they are saying a male policyholder age 65 is known to be in poor health, and it has been determined that his mortality is 200% of the AM92 ultimate. That is, he is subject to QX value equal to twice those of the AM92 ultimate table. Okay, calculate the probability that this policyholder will die before age 67. So see, they have said that our QX value from the table, QX value is actually 2 times the QX value of the AM92 table. So the person is age 65. Okay, 65. So we are talking about the person lives to P65. Okay, sorry, 2Q65. 2Q65 I can write it as 1 minus 2P65, and 2P65 I can write it as 1 minus of 1 minus Q65 into 1 minus Q66. So these are twice of AM92 values. So now I can say this would be nothing but 1 minus of 1 minus 2 times Q65 into 1 minus of 2 times Q 66, where both of these value come from AM92 table. Okay, so you can do this, you can just find these values from the table. 15.6. A select life table is to be constructed with a select period of 2 years added to the ELT15 mail table, which is to be treated as the ultimate table. Select rates are to be derived by applying the same ratios select ultimate seen in the AM92 table, that is this. So they have given us everything. We want to make a select table for ELT15. Okay, so where the dash notation Q dash refers to the AM92 mortality. So we are taking the ratio of select periods from the AM92 and treating that are in ELT15 also, we will get the same values. So we have to calculate the value of L60. Now to calculate the value of L select 60, what are the values that we will require? Okay, so I want L select 60. So most likely we'll require Q select 60. Q select 60 we know is 1 minus L select 61 upon L select 60. So here we'll get L select 60 if we were able to calculate, it will be select 60 plus 1, right? We select 60 plus 1. Okay, because the selection is done at age 60. So if we can figure out this, then we will be able to figure out this. Then where would we get this value? This value we will get from Q select 60 plus 1. Q select 60 plus 1 will give me 1 minus of L, because we are saying 2 years of select period. After 2 years it becomes an ultimate value, to L62 by L select 60 plus 1. Now we can also calculate these values from the equation that they have given us. We're talking about Q select 60 would be equal to Q dash select 60 dash comes from AM92. Okay, Q dash 60 and then Q60. So let's find this. So AM92 ratio, we'll take AM92 here we want LQ values actually. Q values 60 and select, see we want select 60 and select 60 plus 1. So select 60 is going to be 0.00577 on select 60 plus 1 would be 0.00868. This is the ratio. Now we have to multiply what? We have to multiply Q60. Q60 that comes from ELT15. ELT15 male, I guess. Right? ELT15 male, yes. ELT15 male tables. So ELT15 male tables, we require Q60. Q60 0.01392. So this value becomes 0.0092597. Same thing now we have to do for the next one. Next one is Q select 60 plus 1 will be equal to Q dash select 60 plus 1 upon okay, I did not take the correct ratio here. Okay, I should have taken Q select 60 divided by Q 60 ultimate value. I did not do it correctly. Now take the correct value of AM92. AM92 T Q select 60 and then Q ultimate 60. Ultimate 60 is the third column. Q ultimate 60 was 0.008022. 8022. So 0.0100192. This is what we'll get, and here just get 61 and Q60. Let's find this from the AM92 table. From AM92 table, I want select 60 plus 1. Okay, select 60 plus 1. That is the middle column for 61, 0.00868 divided by ultimate 61. Ultimate 61 will be 0.009009. Then into, we'll go to ELT15 male. ELT15 male Q61 gives us 0.0156. We know L62, this will come from ELT15 male, so I'll say L select 60 plus 1 will be equal to minus Q. So just have L62 by 1 minus Q select 60 plus 1. L62 we'll take from ELT15 male, so L62 84 173 by 1 minus Q select 60 plus 1 is this 0.01500303. Okay, now we can use this here to find this. So L select 60 will be, just find that. I'll be back in just 1 minute. Okay, so select 60 will give us L select 60 plus 1 by 1 minus Q select 60. So we have this answer upon 1 minus 0.0100192. 86322.33. Let me just make sure we have the correct answer. Yeah, 8683 point. Okay. Let's go to chapter 16. So, chapter 16, page 18 and 21. This is page 18. This deferred annuity, we did prove for term annuity. You have to just use the same logic to prove that deferred annuity would be equal to this. So first of all, present value will be equal to 0 when kx is less than n and v raised to kx plus 1 when kx is greater or equal to n. So you will say expected present value will be equal to summation k going from n to infinity v raised to k plus 1 kpx qx plus k. This is what we write it as n slash ax. Now if we want to make it into 0 to infinity, we will add the rest of the values. K going from n to infinity v raised to k plus 1 kpx qx plus k. We'll say plus and minus k going from 0 to n minus 1 v raised to k plus 1 kpx qx plus k. If we add the 0 to n minus 1 value, one of them will go from k equal to 0 to infinity v raised to k plus 1 kpx qx plus k, and then minus summation k going from 0 to n minus 1 v raised to k plus 1 kpx qx plus k. This is ax minus ax dash n. If you want to prove the other one, you can just take this for this summation n going k going from n to infinity v raised to k plus 1 kpx qx plus k. We did this for proving a term assurance. We'll say m is equals to k minus n. Substitute that, m going from 0 to infinity v raised to, instead of k you can write n plus m plus 1 n plus m plus px qx plus n plus m v raised to n px m going from 0 to infinity mpx plus n qx plus n plus m. This is v raised to n px a x plus n. Twenty-one. I've not yet talked about covariance because I did not want to confuse you yet. We'll talk about covariances and stuff later on. Okay, so we'll solve this later on, not now. Okay, right now I want you to concentrate more on the expected present value and the variances, not on the covariance. Okay, so 16.2, 16.5. The benefit payable under a special assurance policy has present value random variable W is equals to this max of kx plus 1 comma n, whichever is higher. Okay, where kx is a courted future lifetime of a person currently aged exactly x. Describe the benefit paid under this policy, express expected value, and this. First describe. Okay, so we are saying max of this. That just means W is equal to, the payment would be V raised to n if kx is less than, or if it is less than n minus 1, less than n, and payment would be V raised to kx plus 1 if kx is greater or equal to n, right? Whichever is maximum, that is what the payment is supposed to be. So the description becomes, the payment of 1 is given at time n if the death occurs before n years, and given at the end of the year of death if the death occurs after n years. Okay. Then express expected value EW in terms of the standard actuarial notations. So we'll say expected present value will be equal to summation k going from 0 to n minus 1. We'll have V raised to n kpx qx plus k, or you can just write probability kx is equals to k, and then plus summation k going from n to infinity. We'll have V raised to kx plus 1, or actually V raised to k plus 1 kpx, or I'll just write probability kx is equals to k. Now this is our deferred whole life. This is our deferred whole life. Okay, so here we will have V raised to n, payment given at time n, and this would be, we have done this before, this would be nothing but nqx. Okay, this is nqx. So anybody who dies within those n years, the payment would be given at time n, right? Then plus this is just deferred, so V raised to n npx a x plus n, deferred whole life. Then variance of W. For that you will have to calculate expected present value square first. Expected present value square, we'll have summation k going from 0 to n minus 1 V raised to 2n. Probability does not change. Okay, and then plus summation k going from n to infinity V raised to 2n, or V raised to 2 k plus 1. Probability kx is equals to k. This will just be V raised to 2n nqx, and then plus, here we'll get V raised to 2n npx 2 ax plus n. Variance, just be expected present value square minus expected present value whole square. V raised to 2n nqx plus V raised to 2n npx minus whole square. If you, let's not simplify, let's leave it like this. Okay, this is good enough. We can definitely simplify and we might get a good simplification, but let's just see first whether we are getting good simplification or not. Which question was this? This was 16.2, I think, right? Yep. They have also left it like this because most likely we are not going to get a good simplification. Okay. Then 6.5. In 16.5 we have L40 given as 1000 and L40 plus T is given as L40 minus 5T for T going from 1 to 10. Calculate the value, endowment value. Okay, so endowment value 4010 would be our A 40 dash 10 and then plus V raised to 10 10px. Okay. So of course we are calculating using these, so we will be making a 40 dash 10 formula. Okay, so this would be summation V raised to k plus 1, k going from 0 to 9, and then we will have kpx qx plus k. Okay, probability k, x is how much? X is 40, k 40 is equals to k. So this is what gives us kpx qx plus k, but we can also write it in terms of dx plus k upon lx. Because the terms are given in terms of lx, I would prefer writing it in terms of lx. Okay. So I can write this as summation k going from 0 to 9 v raised to k plus 1, and then we'll have d x plus k upon lx, or in this case we'll have 40 and 40. Okay. X is 40. Now here, how do we find d40 plus k? So d40 plus k will just be L 40 plus k minus 40 plus k minus L 40 plus k plus 1. So in this, if I just substitute, instead of t, if I substitute k here, okay, k and k plus 1, what do we get? We'll get L40 minus 5k minus L40, I'll write it down here, minus L40 minus 5k plus 1. L40 minus 5k gets cancelled out and we'll be left with just 5. So d40 plus k for all values of k going from 0 to 9, we are literally getting d is 5. So our A 40 dash 10 will be now, see, this is 5 constant, this is L40 is already constant 1000. I can take them out, so I can say 5 by 1000 summation k going from 0 to 9 v raised to k plus 1, that is v plus v square plus v cube and so on till v raised to 10. So I can write it as annuity 5 by 1000, and I'm left with a annuity in arrears for 10 years. This is what we are getting. Okay. Now what was the rate of interest? Rate of interest was 6% per annum. So a 4010 endowment value plus 1.06 raised to 10 into, we will have L40 L50 by L40. If I put t is equals to 10 here, t is equals to 10 here, to find L50 I will have 50 minus, so 1000 minus 50, 1000 minus 50 on 1000. So in total we have 1.738. I made a small mistake. What did I make mistake? It should be 1.06 raised to minus. First thing, we should always see that our level assurances will always be less than 1. As soon as I saw 1.7, I was confused that I might have been making mistakes. So yes, I'm making mistake. The mistake is raised to minus. But now I cannot use answer. I will have to put in the value, that is 0.0368. Yes, now you can see that the value is less than 1. Our assurances are less than 1. Simple increase, compound increase assurances can go more than 1, but level assurances will always be less than 1. Okay. And annuity will always be more than 1. Let's do these sums. Chapter 18. (18.1), which one? First and fourth. 18.1, first and fourth. Calculate the value of each of the following functions using the given basis. ADU 6520, AM92 mortality 4%. So this will just be ADU 65 minus V raised to 20, 20 P65, A 85 ADU. What was the problem here? You can look up all of these values in the table. Was there a problem? And the fourth part, we have ADU select 55 plus 1 going for 4 years. Okay, so for this we'll have ADU select 55 plus 1 minus V raised to 4p select 55 plus 1, and then after 4 years there will be no select period, so ADU 60. So this we have talked about how to calculate last time in, I think, while chapter 18 only. I gave you a formula of calculating this. So ADU select 55 plus 1 will be equal to 1 minus or 1 plus V raised to 1 P select 55 plus 1 ADU 57. This is the formula. We are talking about 4%, so 1 plus 1.04 raised to minus 1 into P 55 plus 1. I can just look up the Q table. Q table, middle value 55 plus 1 will give me 56. For 56, I am looking for the middle column. So 1 minus, for 56 I will have 0.004903, bracket close, then into, for 4% we require ADU 57. ADU 57 will be 15.195. 15.53894. Minus 104 raised to minus 4. Actually, because this is 4%, you can actually take D values here. Okay, you can actually take D values here. So this would be D. After 4 years, it becomes 60 upon D. Select 55 plus 1. So I'll take this value. D value, D60 would be 882.85 upon, we want 55 plus 1, select, so select 55 plus 1, so 56, middle value, that would be 1058.02, into we want what? A60, ADU 60. ADU 60 for ultimate value, we will have 14.1334. 3.745. Okay. 18.5, 18.7. Let k be the random variable representing the current future lifetime of age 40 and let gk be the function defined as this. Calculate expected value of gk assuming mortality follows AM92 ultimate and interest rate is 4%. So what do we have here? Okay, so we are saying that we will have v raised to 10. Okay. First of all, 0 for first 10 years. If a person dies within the first 10 years, payment is 0. Then after that, we have 10 years and then annuity k minus 9. K minus 9 just tells us that the annuity is going to start. Okay, k is going to be 10, 11, 12 and so on when we are talking about this, right? 10, 11, 12 and so on. So this just becomes k minus 9 because the annuity will just be 1, 2, 3, 4 and so on. What I can do is I can say v raised to 10 a due k minus 9 where k is greater than 10 can be written as a due k plus 1 minus a due 10. I'm just subtracting the first 10 years of annuity from this. Okay, this will be when k is between 10 and 35. Okay. So when k is between 10 and 45, I can write it like this. Okay. And later on after 35, it is just whole value, right? Okay, so here not a big problem. We can also write v raised to 10 a due 25 as a due 35 minus a due 10. Okay. You can see these do not have any k values. Okay, so for this what I can do is I can directly write the present values. Okay. But these do. Now let's write this in terms of what we can see. Okay, so I'll say g k will be equal to a due k plus 1 minus a due 10 less than equal to k less than 35. Okay, actually instead of this I think the given values are good enough. We'll see if we require this or the given values. I think for now given values are better to use. Okay, a due k minus 9. Okay, and v raised to 10 a due 25 when k is greater than 35. This is what we have. If I make it into expected present value, what we will have is this much into the probabilities, that is kpx qx plus k, going from, so summation k going from 10 to less than 35, that will be till 34 only. V raised to 10 a due k minus 9 kpx qx plus k. Okay, plus this value, that is v raised to 10 a due 25 for anybody who survives that time, that is survives 35 years. 35 px. Okay, so this is no problem. Okay, this we can easily find from whatever AM92. But this, how would we solve it? Okay, so for this what we will be doing is we will say k going from 0, that is what we want. So we'll write m is equals to k minus 10. So now we have summation m going from 0 to this will be also minus 10, so we will be going from 0 to 24. Okay, m going from 0 to 24, v raised to 10 a due m plus 1 m plus 10 px qx plus 10 plus m. So here v raised to 10 I will take it outside, 10 px I can take it outside. So what am I left with inside? M is equals to 0 to 24 a due m plus 1 I have mp x plus 10 q x plus 10 plus m. So now a person age x plus 10, person who is age x plus 10 would survive for m years and then dying within the next years would get this much annuity. This is our a due x. Because we are going only for 24 years, so this is temporary annuity. px. So this becomes v raised to 10 px a due temporary annuity for 25 years. So a due x 25 and then v raised to 10 35 px a due 25. Actually this total will actually make this total will make this. Okay, because this is also part, v raised to 10 comes out and v raised to 10 comes 10 px comes out, and we will have a due 35 sorry a due 25 px plus 10. This total will make this temporary annuity. Okay, temporary annuity formula. So this is what we'll get. You can now calculate for AM92 easily, right? AM92 4%. So you can clearly see if the person survives for 10 years, then a temporary annuity. So instead of x, this is actually x plus 10 for 25. If the person survives for 10 years, then a temporary annuity starts for 25 years. I think 18.7. An impaired life age 40 experiences 5 times the force of mortality. Now see, first thing, whenever they are using the term force of mortality, you will never be using force of mortality from the table book. Every time mu x is given in our table book. But unfortunately, the way we calculate force of mortality here is not the same with which they have calculated the force of mortality in the table book. So even though we have a force of mortality in the table book, we will not be using that. Okay, so 18.7. So what we will be doing, we'll be we'll just talk about that. Okay, and impaired life age 40 experiences 5 times force of mortality of a life of the same age subject to the standard mortality. A 2-year term assurance policy is sold to this impaired life, and another 2-year term assurance is sold to a standard life age 40. Both policies have the sum assured of 10,000 payable at the end of the year of death. Calculate the expected present value of the benefit payable to each life, and that standard mortality is this. So we know for standard mortality, expected present value will be equal to 10,000. They're saying 2 years. So 40 to so this is what our value would be for standard. Let's talk about impaired life. Impaired life. Okay, for impaired life, they are saying our mu x star, new mu x is going to be 5 times the mu x. Okay. Now here, what we will be assuming is, see, whenever we are solving this type of sums, we will be assuming constant force of mortality for a certain age. So within 1 year, we will be assuming a constant force of mortality, and beyond that, we will be every time calculating a different constant force of mortality. So we are going for 2 years here, age 40 to age 42. So we'll be calculating 2 constant force of mortalities, okay, for those ages. So you will be calculating mu x. Actually, what we want is our A 40-2 will be what? Payment given at time V to anybody who dies in the first year, and then payment given in the second year to anybody who survived the first year and died in the second year. Okay. So for these we will be have to calculating mu star 40 and mu star 41. Okay. So what is P40? P40 is going to be e raised to minus mu star 40. Okay. So I can say that is e raised to minus 5 times mu 40, and that is why this becomes e raised to minus mu 40 the whole raised to 5. This is the AM92 mortality value. Okay, so I will say this is P40 for AM92 raised to 5, because we are assuming constant force of mortality. Okay. So let's take AM92 P40. So instead of P40, I will take Q40, right? So Q40 1 minus 0.000937 raised to 5. This is what our P40 is going to be, 0.995324. Okay. We can find Q40 as well, because we'll need Q40. 1 minus of this, minus of this, 0.004676. 2, 3. Okay. Now we'll require Q41. For that, again we'll say P41 must be same as P41 for AM92 raised to 5. So again we'll take Q41, 1 minus 0.001014 raised to 5 and we actually want Q41. We don't want P41, so I don't really need the P41 value. Q41 value will be 1 minus answer 0.0050597. So as I said, we will not be taking the mu values from the table, even though mu values is what we are relating. So these table mu values, this AM92 mu values, we will never be using. Okay. I've never seen a question where they ask us to use the table mu values. Okay. Because I think they have used some other methods to calculate the mu, and we use constant force of mortality to figure out our mu values. So using that, we have calculated these values now. 40-2 for impaired life. Okay. 18.8, 18.9. 18.8. Assuming that the force of mortality between consecutive integer ages is constant in AM92 ultimate table, calculate the exact value of A bar 52 using a rate of interest of 4% per annum. Okay. So they're saying, assuming a constant force of mortality between consecutive integer ages. So that means if you're talking about 52 going for 2 years, we will be saying mu 50 is constant and mu 51 is also constant. Okay, that is what our assumption is going to be. Okay. So for 1 year, these are constant values. So when I say A bar 52, first of all, this is endowment value. So endowment value, we'll write the death benefit and maturity benefit separately. So for death benefit, I'll say integration, because only for 1 year these mu values are constant, I will be going only for 1 year. I'll say going for only 1 year. If the person dies within that year, then survives for so see, at time t, if the person survives till time t and then this is 50, okay, and then dies within immediately, okay, so mu 50 plus t, okay, dies immediately, then the payment is given, okay, for 1 year only. And for the second year, we'll say if the person survives, so we P50, if the person survives 1 year, then second year we will do the same thing, v raised to t, tp51 mu 51 plus t dt. So this mu 51 plus t is just a constant value, it's just mu 51, okay, for these 1 year. Then plus survival benefit will just be v raised to 2 2p50. let's just calculate this without actually calculating the mu value. So let's say integration 0 to 1 v raised to t, we'll have e raised to minus mu 50 t, and then this will also be mu 50 dt. I can write this in terms of e raised to minus delta t. So we'll have mu 50 integration 0 to 1 e raised to minus delta t e raised to minus mu 50 t dt. Combine this and then integrate. We'll just say mu 50 bracket e raised to minus delta plus mu 50 t on minus delta plus mu 50 0 to 1. When we put 0, we'll just get 1. So this becomes mu 50 1 minus e raised to minus delta plus mu 50 upon delta plus mu 50. Same thing will happen for 51 as well. V raised to t tp 51 mu 51 dt must be equal to mu 51 1 minus e raised to minus delta plus mu 51 on delta plus mu 51. Now how would you calculate these constant force of mortalities? Q values are given to us. Okay, so Qx is given to us in the table, that is 1 minus Px, that would be 1 minus e raised to minus mu x. Okay, so if you write this, you will get your mu x would be minus log of 1 minus Qx. Using this, find mu 50 and mu 51. Substitute these values and you will get these two integrations. Okay, these two integrations. V P50 again from the table book, that is AM92. This also from AM92 directly. Okay. (18.9) In a mortality table with 1 year select period, Q select X is equals to A into Q select A into Qx for all x greater or equal to 0 and for a certain constant A. Let kx plus t current future lifetime of a person age x plus t who becomes select t years ago, and kx current future lifetime of a person age x whose mortality is reflected by the ultimate part of the mortality table. Explain whether the expected value of this is less than, greater than or equal to this. Now because the select period is 1 year, we know after the 1 year select period, the effect of select period goes away. So therefore expected value of this k select x plus 1 will be equal to expected value of this k x plus 1, because in 1 year the effect of select goes away. Calculate A bar 4520 based on the following assumptions. A is given to us, rate of interest is given 4% and ELT 15 male. Now you see here they are saying financial functions using ELT 15 male mortality are given on page 136 of the tables. Let's go to page 136 of the tables. Okay, so page 136. This is page 136. You can see annuity values allowing for mortality only on the basis of ELT15 male. So you can see for ELT15 male, they have given us certain values. So from here we can find A bar 45 20, right? When X is 45, A bar 45 20 would be 13.197. This we can get from here, right? Then if we want to calculate capital A, we'll say capital A bar 4520 must be equal to 1 minus D of A bar 4520, right? Okay, so 1 minus 0.04 by 1.04 multiplied by 13.197. So now we know the ultimate value. We have to calculate our select value. Now see, our A bar 4520, we know after 1 year the select period goes away, right? After 1 year the select period goes away, right? So I can say this is approximately 1 plus I raised to half of our A 4520, and I will just try to make a basic relation from this. I'll say A 4520 must be equal to, if the person dies in the first year, the payment would be given this. If the person survives for 1 year and dies within the second year, payment would be given at the end of second year. And similarly, V3 P 2P 45 Q 47, and this goes on for 19 years, and then we will have pure endowment and whatever. Okay, for now I am not writing anything there. Now here what I can do is, or let me just write in terms of this dash. Okay, dash, and it goes for 19 years. We understand, right? V raised to 20 19p whatever. Here I can say this would be nothing but V, and if I take out Q45 plus 1V and P45, if I take out these two, P45 from this, first of all I am taking out 1V, so I'm left with V Q46, then plus V square. Out of this I am taking out 1P45, so I am left with 1P46 now, P46 Q47 plus V cube, okay, 2P46 and Q48, and this goes on for 18 more years because I have already 19 more years. This was going for 20 years, this is going for now this 1 year, and then this is going for only 19 years. So this becomes VQ45 plus VP45, and we'll have A 46-19. 46-19. Now, if I want to write it in terms of select, A select 45-20 would be equal to, same thing if I write, I will get V Q select 45 plus V P select 45, and they said the select period is 1 year. Because the select period is 1 year, 46 will be 46 dash 46. From this we can calculate this. Okay, from this we can calculate this. Again, these values come from AM92, sorry, ELT15 mail. You have Q45, P45 values from ELT15 mail. Okay. Okay. This is what it is. Okay, so using this you will first calculate this, using this you will calculate this, and then you will get this. Then they said Q select 45 is A times Q45. Again, Q45 comes from ELT15 mail tables, and A is given to us, whatever A is 0.9. So you'll get Q select 45. Q select 45 is 1 minus P select 45. Substitute that, then you will get this. And then your A bar select 45 20 will just be 1 plus I raised to half A select 45 dash 20 plus B raised to 20 P 45. Just reversing everything. You just have to substitute, find all the values and solve it. Let's go to assignment chapter 15. Assignment chapter 15 to 18. Five, 7, 15 to 18. Question number 5. Question number 5 says, calculate the expected present value and the standard deviation of a whole life assurance contract sold to male life age 40, which has a death benefit of 100,000 during the first 20 years and 200,000 thereafter. The benefit is paid at the end of the year of death. So see, for the first 20 years, so from age 40 to age 60, we have 100,000. And from age 60 to age whatever infinity, right? We are talking about whole life. Yes, whole life. We have 200,000. So the expected present value we'll say 20 years of term assurance of 100,000. So we'll say 100,000 A 40-20 plus 200,000 after the person survives for 20 years only, then it will start. So V raised to 20 P 40, and then we'll have A 60. So you can solve this and you can directly take this 2040 from AM92 table, okay, or however you want to solve this. Okay, you will get these values. When you're talking about expected present value, okay, let's do this. A 40-20 will give you, let me see, these are all payable at the end of the year of death, or benefit is paid at the end of the year of death. Okay, no problem. Okay. So this will be ultimate 6%. Let's calculate V raised to 20, 20p, 40 for 6%. 1.06 raised to minus 20 into, now we'll go to L table, L60 by L40. Sixty-nine two eight seven into 164 49,856.63. Okay. So A40, A60, 6%, 6% tables, 6% tables, A40 and A60. A40 would be 0.12313 minus answer into 60 is 0.32692. into A60. A60 0.32692. So this is our expected present value, 21917. We have to calculate the 21917 point whatever, 0.97. You have to calculate the expected present value square. Expected present value square, we'll just say 100,000. 2A40-20, 100,000 square. Okay, because present value will also become squared. Constant value becomes squared. Okay, so 200,000 squared. We'll have V raised to 40, 20p 40, A 2A60, 2A60. 2A40-20 will give us 2A40 minus V raised to 40, 20p 40, 2A60. So V raised to 40, 20p 40. I'll just multiply 20 more here. So 1.06 raised to minus 20 into 0.293802 0.09168089. Okay, so 2A40, 2A60 from the tables. So here last column is of 2A, 2A40, 2A60. So 2A40 0.02707 minus answer into 0.14098 155. We'll have 100,000 square into answer plus 200,000 square into 0.0916089 into 2A60 was 0.14098. These are expected present value square. Expected present value square will be 658,150,748.8, and variance of present value will be equal to this much minus expected present value square. Expected present value was 21917.7 square. This is the variance. I prefer writing it in terms of standard deviation square, so I'll say root answer. Anyways, we want standard deviation, we don't even want variance. So it's a standard deviation of present value be 1333.417. Okay, let's see question number 7. A life age 65 exact buys a single premium whole life assurance policy which pays a death benefit of 100,000 at the end of the year of death. Mortality follows a select table with 1 year select period and the following values are provided. Calculate the single premium to be paid. So clearly they are saying 1 year select period. Okay. Calculate the single premium to be paid. So first of all, our premium, single premium will be equal to 100,000 at the end of the year of death, whole life assurance policy for age 65. So A select 65. This is what we want. Now, similar to what we made before, our A select 65 will be equal to VQ select 65 plus VP select 65. Now because the select period they are saying 1 year, they are saying 1 year select period, so then that becomes ultimate value. A66 is what we will be getting. So A66 we have, right? A66 we have, but we need to find what our Q and select and QP is. This is okay. So what we'll be using is A65 will be equal to VQ65 plus VP65 A66. So here we'll just calculate the Q65. This is also 1 minus Q65. Okay. So this would be A65 is equals to VQ65 plus V1 minus Q65 A66. So I will get A65 minus VA66 will be equal to VQ65 1 minus A66. 65 minus 1.08 raised to minus 1.08 raised to minus 1 into 0.5591 divided by V 1.08 raised to minus 1 into 1 minus 0.5591. Okay, 0.0576. Then we know what is our Q. Select 65 would be 0.75 into answer. Give me 0.0432. 0.0432. Okay. So now we want this 1.08 raised to minus 1 to 0.0432 plus 1.08 raised to minus 1 into 1 minus 0.0432 into A66. What was A66? A66 was 0.5591. This becomes our A select 65 now. 535321. Single premium was how much? 100,000. So 100,000 premium becomes 53532.1. Okay. Let's quickly see question number 15. Assume that each of 10,000 independent lives age X subjected to a constant annual force of mortality is 0.04 is insured for a death benefit amount of 1 payable at the moment of the death. The benefit payment are to be withdrawn from an investment fund earning delta is equals to 6% per annum. Calculate the minimum amount at time is equals to 0 so that the probability is approximately 0.095 that the fund will be sufficient to withdraw the benefit payment at death for each individual. Now, these kind of questions we are yet to do. I told you there are 3 ways of calculating the premium. One of them is this. Okay, so we'll be learning this first using probability and stuff. That is what is left for that chapter number 20. And after we do that chapter number 20, this will become very easy. Okay, or maybe at least we'll understand how to solve this. So we'll do it after that. Okay. 18B. That means the second one. So we're talking about AX, and that is our endowment value must be equal to AX T plus dx plus t upon dx AX plus t n minus t. State whether the following equations are correct or not and whether they are applicable. Now we know this value AXN. I'll just write LHS, or I'll actually use this value first. Okay, right hand side we have AX T plus this D. Instead of D I'll write V raised to T TPX, because for us visually V raised to T TPX is easier to understand. And then A. For this endowment, or first I'll just write this X plus T n minus T. What I'll do is both of these endowment I will separate them out. So I'll have AX dash T plus V raised to T TPX plus V raised to T TPX into AX plus T dash n minus T, and then plus V raised to n minus T n minus T P X plus T. I'll take AX dash T plus V raised to T TPX AX plus T n minus T together is 2, and then this plus V raised to T TPX. Okay. And then these two will combine to make V raised to N NPX. Okay, V raised to N NPX. Now this is term assurance for age X going for T years. That means if the death occurs within T years, then the payment would be given. Then here we are saying if the person survives T years, then for the rest N minus T years, payment would be given if the person dies within that time. So clearly this all together is just death benefit. Death benefit of 1 given if the person age X dies within n years. There are many ways of showing this, but here it is not important. Here we'll just write this is X dash N plus V raised to N NPX plus V raised to T TPX, and this becomes AX N plus V raised to T TPX. So clearly they are not equal. This is not equal to our LHS. And why? Because clearly you can see here this is an endowment and this is also an endowment value. There are two payments on survival, whereas here we have only one endowment value. That means only one payment on survival. Just by looking at that we can tell that they are not same. Okay. Rather we know that if it was just death benefit, if it was just death benefit, these two will combine and make this. So if we had dash, dash and dash, then yes, they would have been equal. But because they wrote endowment, 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 that is why they are not equal, because we have an extra survival payment at time T. Okay. So today let's end our class here. We will continue. We were just left with one. We can do it later on next time. Okay. So we'll meet for our Excel lecture on Friday. Okay. Bye.